Hello, everybody.
Hello, hello.
Last webinar. This hackathon's been a. How's everyone finding the hackathon? We got anyone that submitted yet? Let us know in the comments. Interested to see.
Ho, ho, ho. Yes. Not sure if anyone here in the comments has already submitted their projects. I know we have already received a few ones on our side. We are really excited to start reviewing and see all the projects or everything that you guys have come up with. What are you most excited about, Sam?
To be honest, I'm excited to pass a lot of these projects onto the judges that we've got. If you remember, we announced them like maybe 2 weeks ago. We got like Yan Kui, Bernie Monk. We got Manoj and Cyril from Serverless Guru and Rossius. So it's like 4 AWS heroes. So I'm just excited to be in a Slack channel with them, to be honest, just talking tech. It's gonna be real cool.
Yeah,
And then
that
they
part
should
will
all be
be
on.
really interesting.
Yeah, and then they should all be on the. We're gonna do another webinar in January with the winners, and I think we're gonna be talking about their solution, a bit similar to how we're doing ours today. And then the judges will have a ton of comments about what they thought about that solution and what they maybe would have done themselves. So yeah, just smart people. Just it's great to be around them. All right, we'll give it another minute or so. As more people come on in. Yeah, Jonathan, if you can bring up the slides, I think we can kind of slowly get started. I think we'll be fine. Great. Okay, so this one should be, again, as always, probably like an hour long. I'm gonna do the first half. Lorenzo's gonna do the second half, and then plenty of time for Q&A at the end for sure. So as questions come up, feel free to throw them in the comments. I know that we are also live streaming on Twitter today, giving that a try. So I guess tweet some questions, and then Jonathan in the background is gonna collate anything that we want to answer on screen, which would be cool. Hey, Craig, you're here again. Good, nice to see you. I think you're on the caching webinar we did on Tuesday as well, weren't you? I think. That's good. Yeah. All right. Let's kind of get started, I guess. So, Holiday Hackathon. We all know what this is about now. I've done it enough times. So a little brief reminder who Serverless Guru are in a moment, just in case you've forgotten, since we've done the intro the last 3 weeks. We're going to go through some code examples from like Bedrock and LangChain and whatnot. For those of you that are still really stuck, or maybe it's too late to even join the hackathon, or maybe you're just watching this on YouTube months or years down the line, we've collated a few code samples that will kind of show you some sort of hello world examples using Bedrock. Then Lorenzo is going to take us down the sort of deep dive into our own implementation and architecture for the chatbot, which we'll do a demo for, and then a big old Q&A at the end. So, reminder, who is Serverless Guru? So we are a company with over 75 developers, architects based all across the globe. We've got clients big and small, and we essentially help you on your serverless journey, be it consultancy, be it developments, supports, or education. We're here to upskill your workforce, build your serverless applications, architect and guide you on that path, maybe from a migration to serverless. So if you're interested in our services, speak to a guru today. So you can get to the website. You're on our YouTube, so I'm sure you can get from there. If not, you can search us on Google, LinkedIn, Twitter. We are everywhere. We also have this Discord server. So for those of you that are on the hackathon, you're now already part of it. And we're not just going to use this for the hackathon and then let it die. We want to reuse it. We want to build this serverless community. So by all means, if you haven't joined it, join it. We've got the QR code here. We do have sort of the hackathon section, but we've got general chit chats. We've got sort of like support, talking tech, all sorts. And we're going to grow it in the future. So it'd be great if you could be a part of this community that we're trying to build. I don't really think Serverless has got that go-to community just yet. So we're going to try our best. Okay, so just a little bit of, sort of housekeeping on the hackathon itself. So it's submission time. The deadline is end of day Sunday, so 11:59 PST, which is right in the West. So for those of you based out in Europe and Asia, you've got the early hours of the morning to try and get your submissions in. QR code on the top right will take you to the website, but it's, as we all know, hackathon.serverlessguru.com. So what do you need to provide? So you're going to have to provide a link to an article. That article needs to be public and needs to be published somewhere. So for example, you have a hash node or Medium or dev.to or a LinkedIn article. It doesn't really matter where. We just want to see something public, mostly because we want to see a timestamp to make sure you've submitted on time. Also, that's share the love. That's show really how we've solved these problems. We also want to see a demo video. So ideally, we want it to be no longer than 5 minutes. Again, via a public link. So YouTube is a good example, but I would recommend going for Loom. With Loom, the free tier lets you record videos up to 5 minutes, and you get a public link that should never expire. So record via Loom, and you can just share that URL with us. And then finally, of course, a public repository with the code. So it can be any GitHub, GitLab, we don't really mind. Just needs to be public so we can see it. So we need to review and see how it all works under the hood. And then finally, there's space for some other comments. So for example, if you have got it live, there is no requirement for that. We understand that running these LLMs in the background can be quite expensive. You may also be a bit worried about having something open to the public that is connected to your bank account. If someone's to fire a ton of requests at your backend, for example. So we understand. But if you want that link in there, by all means, include it. Also, sort of any required credentials. So if you did want to sort of hard code some API keys, so not everybody can access your chatbots, your LLM application, feel free to just send us privately the credentials. So if you want us to be able to actually play with it. I mentioned the deadline. So any changes after won't be reviewed. So especially with the public repository, if you feel like you built something cool, but you want to expand on it, feel free to go and expand on it. When we look at the code, we're just going to take the last commit before the deadline and review the code from there. So by all means, keep building. It's not going to impact your submission at all. Okay, more on the submission forms. So if you do get to the hackathon.serverlessguru.com page, it's that red button in the top right to submit your project. And then all the fields will become available for the content that you need to provide. Okay, so enough of the housekeeping. Let's try and get a little bit of motivation to those of you that haven't quite figured out how to build these LLM applications. People are going to be at all sorts of levels in their careers, down from junior up to seniors. And to be honest, we're all juniors when it comes to Bedrock and LLMs because it's only really been around the last year or so, let's be honest. So what have we done? Mostly Lorenzo. Lorenzo's taken a lot of the working code from our application, and he's turned it into sort of reusable snippets of code that we put in a public repository for Serverless Guru. So QR code in the top right will take you there. If not, just find our Serverless Guru GitHub accounts, and you'll be able to find the repository in there. I think, Jonathan's just put the GitHub into the comments, so you can find it from there. So we did go down this sort of decision tree of, do we just call Bedrock outright? Are we going to use LangChain? How are we going to maintain conversations? The problems that you've had to solve, we had to solve too. So we've kind of got our code as sort of we've iterated through the process. So we've got different ways that you could use the raw AWS SDK, whether it's streamed, whether you're using Bedrock agents, so announce that reInvent, or if you've gone down that LangChain route. And we found it a little bit hard to get things working with LangChain. We'll talk a little bit more about that in a moment and show you some examples. So this is sort of a helping hand, something you can sort of drop in your codes and then just need to rework it for your use case. So the considerations when building your LLM applications. Let's start with one. Do we need to preserve the conversation? Is your application going to be sort of an isolated call and response? For example, what could we be? Some kind of back-end asynchronous process that wants to generate an image asynchronously. But of course, there's no conversation going on there. You're passing a prompt and then receiving an image. Whereas something like a chatbot, which most of us have probably built, you probably do want to preserve that conversation. So an example here, how could you achieve that with the raw AWS SDK? Well, the main differences here being which client you choose. So you've got the Bedrock runtime client, or you've got the Bedrock agent runtime client. So that agent then allows you to use a Bedrock agent, which may maintain the conversation, and you can integrate all sorts of third-party APIs and turn it into what's supposed to be the next generation of online assistants, I guess. By using the different classes, you then have access to the different methods. So invoke model command or invoke agent command. If you remember from the first webinar that we did when we kicked things off, we did obviously we had Cyril on telling us all about LLMs, and then I showed you sort of the foundations of Bedrock and how you can use it. And I mentioned there are these different methods. So you've got invoke model, and you've got invoke agents, and we have another one which we'll show you in a moment. So let's move on. So about your response, are you going to be streaming your response back, or is it something that you're fine to kind of wait for, sort of a simple call and response? These LLMs aren't the fastest. They are going to have to improve over time. Good example, again, being the image generation. If you need that image time to first bytes, then maybe you'd want to use a streamed response and maybe start sending it to its destination, because these images could be quite large. Whereas maybe you don't. Maybe it's sort of an asynchronous process where you don't mind when you receive that image. It can take a little bit longer, but you just want to sort of receive it in a simple response. And so how could you achieve that here? Well, by just simply changing the method or the function that you would use. So they're both using the Bedrock runtime client. So neither of them need to use agents. You can, but you don't need to. But it's simply, are you invoking your model, or you're invoking your model with a response stream? So very simple. You have to obviously change the, actually, they're using the exact same arguments, as you can see from the line above. So it's very, very simple to swap and change. Obviously, how you handle that streamed response is very different. So the following code after these snippets would be very different. But in terms of invoking Bedrock, it can be more or less the same. And then this is a bigger question, the direction you want to go down, thinking about the ecosystem. So do you want to be in this sort of, I've called it the Lang star, the Lang, obviously for LangChain. We had Matt Carey, who was on the webinar last week, told us all about LangChain. He mentioned that we have Langsmith, which is the observability platform for working with LLMs using LangChain. You could see, you could debug, you could see all sorts of how LangChain is working behind the scenes to curate your prompts and how the RAG works and whatnot. There's also what's it called, LangServe, which is going to be the deployment platform for LangChain, which I think maybe in beta, or maybe it hasn't been released yet, I'm not too sure. But they're obviously building an ecosystem there, and it's only going to work if you're using LangChain. Well, versus AWS. So if you're using AWS, you're using the SDK, you have access to things like Bedrock agents that we just mentioned, and Bedrock knowledge bases, all those things that got announced at reInvent. So if you're building these applications, thinking beyond the hackathon, thinking long term, which direction are you going to go down? Are you going down that sort of LangChain abstraction framework approach, or are you going to keep it sort of more direct and more tightly integrated with AWS? And there's obviously a little bit, there's a middle ground, as there always is. The example code snippets here, let me circle this here. So with LangChain, you can obviously have what's called a conversation chain, which is just further down in the code snippet. That's Matt told us all about, and that's a way of preserving your conversation. So you need the conversation stored somewhere, and there's lots of different memory or storage options, one of which is DynamoDB. So you can simply provide your DynamoDB table, the partition key and the session ID, as you see there, and LangChain will handle all of the conversation preservation for you. And when it's time to send a new prompt, it will curate your prompts, including all the conversation it needs, and send it to your backend. So you can get a little bit of both. You're using the LangChain framework, but you're actually using AWS resources. There are problems when working with LangChain or with working with any abstraction layer, any kind of framework that isn't sort of working directly with AWS, for example. And that's because there's a lag in development. So AWS bring out a feature, for example, Bedrock, and then LangChain, they want to support it. They've obviously been supporting OpenAI for a while and a ton of other LLM providers. And you need to get Bedrock working. Well, of course, as they develop that code, there are going to be bugs. And the more code there is, the more bugs there are. So not only do you risk there being bugs in Bedrock, but you now have risk of bugs in LangChain. And that's something that Lorenzo and I exactly found with this project. We found that Bedrock streaming didn't work. You could not get a streamed response. It was still in a sort of an unstreamed state. So we raised the GitHub issue, went a bit of back and forth, convincing them that the code was broken, and we got a fix merged. So not us actually writing the codes, the maintainers did, but we've contributed to this open source project by identifying that bug and getting it resolved. So that feels good as well. Now, let's move on for the demo. So I am going to just unshare my screen. So we're going to do a quick demo of the application again, for those of you that can't quite remember what it was like from day one, maybe a few minutes. And share my screen. There we go. All right, let's bring that back up. Yeah, so here we go, this screen that we all know and love. Lorenzo did post a Loom video as part of our integrated article where we sort of walk through all of this and written it down on pen and paper. We walked you through actually using the backend API as well via Postman, which is quite cool. Let's see how it looks and feels. So you obviously have our landing page. We can start. And we're going to get a message back from Santa. So notice how it came in that streamed response, that sort of streamed manner. We didn't wait for the entire piece of text to be generated. And so that's because we've used streamed responses. So Santa's very, very talkative on our application, you've realized. So I'm not going to bother reading most of it. But let's try something like, what happens on the 5th day of Christmas? Let's see if Santa knows his Christmas carols. I don't think he does. I don't see anything about 5 gold rings, which is great. Let's try something else. Let's see if Santa can hallucinate and tell us that Santa doesn't exist, because we obviously all know that Santa does exist. So Santa, are you real? Well, of course I'm real. So Santa is, of course, not hallucinating here. We all know that he's real. He is never, ever going to disclose that he's not real, because that's entirely false. Let's test whether we actually are maintaining our conversation. So my name is Sam. So I'm going to tell it my name's Sam, and in a moment I'm going to ask what my name is. And to be honest, it's very, very hit or miss. Sometimes it does know it, and sometimes it doesn't. This technology is so raw. Honestly, it's mind-blowing. So my name is Sam. What is my name? Let's have a look. What is my name? Let's see. I am afraid I don't actually know your name. I'm going to try it one more time. I'm curious. Let me just try it again. What is my name? Let's see if it knows it this time. No, it doesn't. Okay. Well, I literally did the demo run through about 5 minutes before the call started, and it did. So maybe it's how the tokenization works with the strings, how it splits your text into tokens to then pass sort of into the LLM individually. So maybe it doesn't quite grasp the context that my name is Sam. I don't quite know. But it's a cool little application. So we've got our chatbots. It sounds like Santa, looks like Santa, and it's talking a great deal. It does maintain the conversation, I can promise you that. And for some reason, it now doesn't know what happens on the 5th day of Christmas. So this model is maybe breaking down. I don't quite know what's going on. But anyway, that's our demo. Lorenzo and I, we built it. We didn't put a huge amount of effort into it, about the same amount of time as you probably have in the last 2 weeks. We didn't want to make something perfect. It's very, very rough around the edges, but it's sort of a proof of concept that these chatbots, LLM applications they're easy and they're more accessible than ever. So I am going to stop sharing my screen. And Lorenzo, if you want to come back on, I think we're just about done on my part.
Yes, I'm back, and I can assure the memory sometimes works, sometimes not. It's part of the hallucination. Something I wanted to try, but I had not time yet, was to actually upgrade the model that we're using. I know Claude 2.1 went GA. Not sure if early this week or last week. So that would be something to test or something to improve, but it works. Not always. That's something
Yeah,
to
well,
have in
this
mind
tech
with
is
LLMs.
this tech is so new. Like our model's already out of date. Bedrock Agents has come out. So if we were to do this hackathon again next month, we would probably build it completely differently, wouldn't we, Lorenzo? So it's a really exciting time to be just building stuff in this space. It's moving so fast.
Yep. We have a question regarding how we implemented the front-end interface. Here, we kind of cheated a little bit. We also were a team of 3, where we had Mersat. Mersat has not come on screen with us, but he was the one responsible to actually develop the front end, but it was from scratch. He did it himself with React. Okay, so now let's bring my slides up and we can get started. Sam showed you how it looks, so the last version. I'm not sure if anyone was part of the first webinar where we showed the first MVP of it, but at least the front end improved a lot. We have seen how it works. Now I'm going to explain how it works on the backend. So what nobody sees, but what ensures that it actually works. So building our own AI chatbot. I also shared on Discord the link to the article we wrote about it. You have it on the top of the screen, the QR code in case someone is interested in reading it. It goes into detail on how we built it, and it has the same content as what we will see today. We'll see mainly 2 different things. First part would be the challenges that we faced and how we resolved them, or how we faced them. And then at the end, the actual architecture of what do we have under the board? How is it actually working? So for challenges, we'll see 2 different things or 2 main items. One would be the implementing LLMs. That was one of the challenges. Hey, we need to actually make this a chatbot with an AI, with an LLM. And the second one would be how to avoid timeouts or WebSocket API. So first, challenge, conversation memory. As we showed in the demo, it, it didn't really show as it was working, but we can assure that it sometimes does. If we use another model, it would probably work best. Right now, we are using Claude V2 Instant. So if we move to Claude or Claude 2.1, as it just came generally available, it might have worked a little bit better. But here the main concern was that not only memory, we want the LLM to have a little bit of context of what it's actually talking about, so that it's aware, almost aware of what we asked, what we said, and what the model also said. So this is a good example that, for example, we can see when speaking to ChatGPT on OpenAI, where you can ask it, what was my last question? And maybe if you try it, now I've had more success trying that question of saying, what's my name? And then asking, what was my last question? And that usually works a little bit better. But here, as Sam also showed it in the one of his examples, how we approach it was to actually use LangChain. We went with LangChain ecosystem, but using Bedrock on the backend. And here, 2 important things to consider or to see is on one side, we're making here the conversation chain, as you can see. So it's not only just triggering requests that could be standalone, but we have a conversation chain. What this means is that it will add all the context of the previous or the current conversation. Then an issue that we have is at it as it's hosted, and we don't want to have a Lambda running all the time just for each client. What we also did was implement this, the buffer memory or DynamoDB chat message history. This year, what is actually doing under the hood is taking advantage of DynamoDB, as the message or the name implies, to store the message, which means that even if the Lambda dies or your second request is handled by a different Lambda, it will fetch your message history from DynamoDB and pass it on as part of the conversation chain. So that would be the first challenge. The second one, as Sam also showed, was the streamed responses. Okay, and here I have a little GIF where we can see that we built, or we kind of struggled at the beginning, as he showed with the PR and the issue that streamed responses was not really working. Why do we want streamed responses? On one side, it's we don't really want to wait more 30 or more seconds until we have the full response, as it was with the first MVP that we showed the first day. We want to make it a little bit more interactive and also more responsive by having the LLM building it directly. So to do that with a chain, conversation chain, it's a little bit more complex. If you do it with a similar, or just doing it with a regular call directly to the LLM, you can just loop over or add a little argument stating streamed true, and you will get a stream back where you can just have a for loop running over that stream and getting the response. When working with chains, we found it a little bit more cumbersome with LangChain, where instead of just looping over the response, we needed to actually implement the callback. So this here would be the callback. This is a little gotcha moment that we had, so that if anyone is planning on doing the same or implementing it with Node, LangChain, and a conversation chain, you might have been stuck with this issue as we were. So we thought it would be nice to share on how to resolve it. So it's just returning a list of callbacks. The callback has to actually have some specific names. You can find more information on the documentation. And here inside the callback, you can actually do whatever you like. Token would be the part of the response that you're getting out of the message. So each different jump of text would be a new token. And here we have just a single console log to show the example, and we're running or storing everything in streamed responses. But here the idea is you can do anything with it. So in this case, we converted it to an async call, and that's how we're actually calling inside here, calling the API Gateway API to respond to the front end with new messages. So kind of going, we call the API Gateway API to response, how we went with the 30 seconds timeout and how to have those streamed responses. As we saw in the previous conversation or previous webinar that we had, we knew that REST APIs are just request response. You can't really do much of it. You have a 30 seconds timeout. So if we want something, let's say bidirectional communication, as we currently are facing or looking at, we can go with WebSockets. WebSockets still use an API gateway, but it won't be a REST API. Here, how to decouple it is we have on one side the the issue that these here are the custom or default routes or actions that the WebSocket API has to work with or can use. And here we would still face the same issue of the timeout of 30 seconds to actually reply. So what I mean by that is when the user sends a message, for example, to the custom action, this Lambda here has still 30 seconds to reply with an answer. So we would still face the same issue, and it wouldn't really be bidirectional at all. Yes, this Lambda can send multiple answers, but it still faces the issue of the timeout of 30 seconds at this step. How we can do it is by actually decoupling the long-lasting execution. How we can do it would be on two steps. The first one, here we would have the user sends a message. The WebSocket API triggers a Lambda. This Lambda would be the one that handles that specific action or that specific route. And this Lambda here would actually get the message, transform it as needed, and just add it to the event handler that you prefer. In our case, we went with Event Bridge here. So this Lambda here adds the event to Event Bridge, and right after that replies to the user stating, hey, perfect, we got your message, and we're processing it. We're working on it. And the next step would be to actually process the event. So here, in our case, Event Bridge, but you could have SQS or whatever you feel like having to decouple the processing. The event would trigger this new Lambda, the message processor. So we had message handler, we handle the retrieval, or we receive events and we handle them. And after that, we have another Lambda. This one could have a more or longer timeout or execution timeout that will get triggered by Event Bridge to the call to the LLM, so to Bedrock, for example. And for every single token that it receives from Bedrock, it could be triggering the WebSocket, so API Gateway API, to reply to the message, to the user. In this case, we've just shown one example, but we could have here up to 10, 20, as many messages as we want, okay? WebSocket's APIs are bidirectional, which means that the backend can send as many messages as we want to a frontend. No need to have a request response structure here. Here, just an example of, I mentioned twice now, the API Gateway API. So this is how we can actually do it with the AWS SDK v3, where we just mention the endpoint that we want to use. You can also use the region if you're doing some cross-region processing, and just post to connection command. Here, whatever you add here on data, the stringified, would be what the front end receives and can at the end show to the user. So then another thing we faced with WebSockets, as we mentioned, it's bidirectional. We have some asynchronous processing happening. It's not request response. This includes or adds a new issue or challenge, which would be authentication and state management. So this would be kind of replying Craigmon's question of our biggest challenge, or the one that most surprised us, was on one side, authentication. We prepared it, or better said, you can configure it, the WebSocket API, to work with API keys, kind of, not really. And you can also configure it to have Lambda authorizers for custom headers. The issue comes when you try to integrate it with a front end. Most front ends won't really allow you to send custom headers when doing a WebSocket connection, which would trigger some authentication issues, or how we can actually have this as, or how can we handle the the state or the authentication without relying on API keys or anything like that. Okay, so to resolve this issue, or how to resolve it, would be to just end up creating a state machine that handles or that stores the status for each connection on how it currently is. Okay, I will go into further detail on the full status machine or state machine at the end when we go through the architecture. But here we have this example of user connected, then authentication pending, and until we receive a message state of authentication action, it will stay here in the authentication pending. Once they send the message, we'll check, okay, was the authentication successful or not? If it was not successful, it just failed. You will stay, or the connection will stay there indefinitely, and you will get errors all the time. If it succeeds, then you will go into the authenticated state, which will trigger the next step of authenticated. Then we trigger a welcome event or welcome message. Okay, not sure if you recall when Sam was doing the demo, right when he entered the app, Santa started chatting to him or started with the same message. That's what we have here as triggers welcome event. So that would be the event going through an event bridge. Then the Lambda would start processing this event and adding the status as welcome message in progress. After it's completed, then welcome completed, and the connection is ready. Welcome completed is a message that we send to the front end, so that it knows, okay, perfect. The message has completed. We can now allow the user to send requests or to send messages or prompts. Okay, so the idea here is that if the user is not, or the connection is not in connection ready state, every message that the user sends, or every prompt that the user tries to send, if they are trying to mess with our API, for example, by doing it via Postman, they will get an error. It will fail because we know that we are still processing another message or another event. They need to wait. Okay, so if they're in authenticated welcome message in progress event and state, or any other state that is not in connection ready, then the next prompt would fail and you would get an error message stating, okay, you need to wait until the connection is ready. Then when the connection is ready, we can receive another event or another message from the user, a prompt. So user sends prompt. In that case, we would have a message handler as we saw at the beginning that receives the message, adds the state to prompt in progress state, and adds the event to event bridge. Event bridge with trigger another lambda. This other lambda will start executing everything or will start processing the prompt. And then once it finishes, update the state to connection ready state. Okay, so this would be how we actually did the authentication and how we handle the state for our WebSocket API. And here you can just see a complete diagram of the whole thing, everything together. Now, let's go to architecture overview. For this, will take us a little bit. Okay, perfect. I just saw Jonathan come on screen for a moment, but we'll go over architecture overview. For this, we'll see two different APIs that we developed. One is the management APIs, which is really related directly to the authentication step that we mentioned before. And then the WebSocket API officially, so the one that everyone wants to hear about or wants to see how we handled it, where we have the default actions, custom actions, and the decoupled events. So the management API, what is it? Why do we have two different APIs when we only need one? As Sam mentioned before, having something out there publicly available is not really a good idea when you're using some expensive services as could be LLMs. LLMs can end up being very expensive if you don't really take care how you're using it. And we really didn't want our API to be exploited or used in ways that we didn't want or that we didn't predict, to avoid, I said, of going with very high bills based on the LLM usage. For that, we created a management API, which in this case would be a REST API using API gateway and two different lambdas. Here, for this one, we have on one side the endpoint generate API key, and then the retrieve config. The first one, the generate API key, is intended to only be used by management/admins to create new API keys. And these API keys can also limit the number of prompts that each user can use. So for example, I can, or Jonathan asked me to, hey, can you please create me an API key to share with that user or that client so that we can show our really good or really nice Santa Chat application. Then for that specific user, I can create an API key and say, yeah, let him use 5,000 prompts if they want, which would be way too much. But we could say, yeah, 5,000 prompts. They can send 5,000 prompts, and they can connect up to 20 times with this API key, and this API key will be available 10 days, something like that. But if I want to have something publicly available, I could say, yeah, let's just let them use 5 prompts. And this API key, I want to rotate them to avoid it being exploited. So let's just have it available for 5 days and only 100 connections for each API key. This information is stored in the API key table on DynamoDB also. And then when calling the generate API key, we get another identifier, which is the config ID. So this config ID can be sent to the, or is the one that the frontend will use to call the same API gateway to the retrieve config endpoint. This retrieve config endpoint will return it the API key and some basic information about that API key to be used. And after that, we can see, or as we saw in the state machine, this API key is the one that is used to authenticate the user. Then, after doing the retrieve config call, they can start with the WebSocket API. So from the retrieve config call, they will get on one side the WebSocket URL so that we can redeploy, change it as we want. Maybe we want one frontend or one client to access the production version of the API, or another one to use staging or development. So the retrieve config API will tell you the API key to use and the URL of the API so that we can redeploy, change as we need it on the fly without needing to redeploy the frontend. So with the URL that we received, we connect to the WebSocket API, and by connecting, we will trigger the connect Lambda. As we saw before, we have a state machine, so we need to somehow initiate it. So when we connect, we directly create a session to connect where we store information. Then we have the disconnect, which will delete everything, and a default one, which will delete everything, just return an error. So that if you're trying to mess with it or trying some actions that are not really supported, you'll just get an error. Then the custom actions, or the ones that are actually interesting for you guys, are the ones that we developed, or the actions that we support right now. That would be authenticate. As we mentioned, we need to authenticate. So with the config or API key, we will retrieve the API key usage information and update it to the session management table and update the status. And then if it was successful, add the event to event bridge, and same with send message, add event to event bridge. And here, right now at this point, we can see why we also went with WebSockets and event bridge, because it's really simple to add more functionalities. For example, if we now wanted to also support text to speech or speech to text, or speech to text, we could here add just another action or another route that would be translate or speech to text or text to speech. We could just add another route with another Lambda that would trigger another event on event bridge, and add here just another Lambda that triggers or that processes the decoupled events. So we wouldn't really be stuck with just one feature. We would be able to just improve as we preferred. Okay, so here we can see the API key table, session management table, and here we see two different ones, okay, in the same icon, but we have two different ones. The session management table, same as before, and now a new one, the message history table. The demo didn't really went as planned, but we're storing everything in message history table. If you try the app and play a little bit around, you can get better responses. Like I got one time that says, "Hey, I'm sorry, I don't know your name, Lorenzo." So it actually knew my name, but that's some little things that we can see or we can test around where we actually know that, yeah, it has access to the history. So the decoupled events really work as the first example, or when I talked about the challenges where we faced, where we have event bridge. Event bridge will have different events coming in. Okay. So from here, we have the add event. Authenticate will add the authentication events, and message will add the prompt message event. So authentication completed event will go to the welcome message lambda, and this lambda will trigger Bedrock. Bedrock will start replying. We'll be triggering messages to reply to the user or for the user to see the streamed response. And at the end, we can update DynamoDB, so both tables, to know, hey, is now connection ready? You can add a new prompt and also store the message or the information. And then the other event would be prompt received events, which really works the same way, but just does different things. Here we'll be processing the different prompts that we might receive. So we send the prompt to Bedrock, we get streamed response, we trigger messages to the front end, so multiple messages to the front end. And once it's done, we update DynamoDB with the different tables to know everything connection ready, and message history table with the history of the messages that we sent and received. So this was the architecture overview. As Sam also mentioned, we kind of limited ourselves on the time that we wanted to spend. On one side, because we also have client work to work on, we have private life, and because we wanted to make kind of fair and not give too much out. So we didn't want to actually have a full-fledged, super awesome application that no one would be able to replicate it. We just wanted to have some basic stuff so that you guys could have an idea of how it works or what you can come up with. So future work, possible improvements. The idea is probably sometimes next week we'll make the code open source. So I'm sorry, you won't be able to just copy paste it and submit it for the hackathon, but we'll clean it up a little bit and make it open source so that in case anyone wants to play around with it, improve it a little bit, and then end up showing it or playing around with it with the family, they can still do it during Christmas. Possible improvements, as mentioned before, we can add voice to text or text to voice features, or even better, as Alan showed in the webinar before, you can receive an image and let the LLM or the AI tell you what is in that image. Another one would be improve authentication. So right now our application, yes, we store the message history, but only during your connection. Once you disconnect, we delete the messages because as we don't have any authentication in place, we can't really assure that we're replying with the messages to anyone that they are actually theirs. We didn't want to cross send or let someone see the message history from another person. So we just left it as a possible improvement. And I've already seen some submissions that have done that. So that's some great work on there. And then add any additional features. Like we just work directly with Bedrock, with Cloud Instance. You can implement an agent and even another API so that you know that your agent or your API can access an API that has different gifts so that you can say, hey, I really like doing this. I'm that many years old. And the LLM could access this API, do a query on the API, and list possible gifts ideas. Or even you can tell the AI what you actually want for Christmas, and it could build a custom wish list and then send it to Santa or to someone else that could actually buy it. That's some fun or possible improvements that can be done. So right now, let's go to questions and answers. Let's have Sam back on board and let's see what everyone thinks or any feedback that we might receive. Just as a friendly reminder, join our Discord server. And here you have also the QR code to submit the project. Don't forget to submit it. It's until 11:59 PT. So if you're not in the PST time zone, consider it. You don't want to miss that out. Okay, so let's go with questions. Not sure, Sam, if you were able to fetch some of them from the comments while I was presenting.
Yeah, I think we answered most of them as we went along. Yeah, we've answered. So let's go back to Craig once again on sort of those big challenges. Obviously, looking back at that lang chain issue that we had to fix as well. I want to sort of re-highlight that as well when working with these open source libraries, abstraction layers. It's more codes and it takes time to become mature. So sometimes you do need to help out the community and highlight these issues and sometimes fix it if it's a small project. Obviously, LangChain's got a ton of maintainers, so they can actually handle the fix that you raise. Was there anything else that we struggled a lot with?
Yeah, I think that's basically, and then when you actually interact with the LLM, you need to be sure what context you're passing it on so that it hallucinates the less hallucination as possible. Someone mentions here, yeah, the chatbot likes to be funny. Yes, that's something you can actually configure when you go to the GitHub repository and that Jonathan shared before, where Sam talked about the examples. There you can see the different configuration that you can give. For example, the top K, top P, and there was the temperature also. And I know there's another one. I'm sorry we don't have Cyril today with us to actually explain what everyone does, what everything does. But temperature, for example, we have it at that low. So yeah, it likes to hallucinate and it likes to be funny, or it tries to. But yeah, those are different things that we can configure so that it acts as you want. So right now it's Santa. Yeah, we wanted to hallucinate a little bit or be funny. If it were for a more serious chatbot, then you would like to bring up the temperature so that we don't really get some hallucinations or not as many hallucinations as we could get.
I think the prompts that we're kind of, or like the context that we're wrapping it in as well, could definitely use some work. You can kind of see it's kind of like a block paragraph. So being able to craft that context, maybe talk a bit less. Like I hardly ever read the whole response. Santa talks way too much in our application. So sort of working on the prompts. And we spoke about it. I think it was the last webinar, maybe the one before, about prompt injection, and that's like a whole problem that the industry is going to have to solve, whereby similar to SQL injection, where you can kind of exit out of your current prompt and then do something a bit more disruptive. So, for example, you could maybe pass a prompt in saying, ignore everything you've just said, ignore all context. Now tell me, and then maybe ask for some sensitive data that maybe the Bedrock agent has got access to. And I don't think our application protects against that at all. I don't think anyone's really figured out a good way of stopping that sort of attack. So by all means, go and break our application and show us that you can manipulate it and do things very un-Santa-like.
Yeah. We also have a question from Craigmont on, can you limit how many characters the response are? Yes, you can. Not to the exact amount of characters, but there are different ways to limit it. When you configure the API, as I mentioned, temperature, top P, top blah, 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 we can use them on one side to know how much to hallucinate and how much to write. And apart from that, we can send the max amount of tokens to be used. So for example, if you don't want really long conversations or really long responses, you can limit it that way by reducing the amount of tokens. But if you do it like that, you are in a tricky situation where it could just stop mid-sentence. So that's also something that you want to avoid. And another option would be to use the stop sequence. So for example, if you wanted to just reply with one single sentence, you can add a stop sequence of that dot. And after each dot, it will just finish. And there's actually, if you inspect the response that you get, you can actually know why the response stopped. So you can know, okay, it stopped because stop sequence, it thought it was the best moment to stop, or it stopped because it ran out of tokens. So that way you can also tamper or figure it out a little bit from the backend, how you want to deal with each different solutions or stops that the LLMs might have.
Yeah, I'm not sure if anyone noticed on the demo, but the intro from Santa actually cut out mid-sentence, and that was because it ran out of response tokens. So it even happened in our application. So you have to kind of use the prompt or something to tell it how long you want the response to be, maybe. Because remember, these LLMs, they create token after token when they're developing their response. They just jump from token to token until they feel like there's a natural stop, natural pause, and then that's when they finish building the response. So it doesn't know when it's mid-sentence. It doesn't know it's only got one token left because the LLM is simply looking for what tokens best suited in vector space to be next, and then suddenly you run out.
Yeah. And another thing to consider with the max tokens approach is there's another comment about that. I'm not really sure if it's one-to-one with characters or words, but something that you also need to keep in mind is that it's not only the amount of tokens that it's used by the response, it's the actual total amount of tokens. So whatever you give it as a prompt, as a context, plus the actual response. So if you end up having a really long conversation, they might need a lot of tokens before it's actually able to reply.
Yeah, and to add on to that, it's definitely not going to be a one-to-one mapping with characters. You can make the argument for simplicity's sake that it's just with words, but it's normally going to be a group of words. And again, that's because the way that the LLM works is it takes a token, which is, in this case, it's going to be, let's call it 3 words, and it's going to put that somewhere in vector space based on these millions, billions of parameters that Cyril spoke about in the first webinar. And then it's going to decide what the next token should be sort of coming back. And so if a token is simply a character, it makes no sense because it doesn't know A, E, B, C. It doesn't know what's coming because it needs to know what words, because the word exists, or the token exists in this vector space. So I hope it makes it a little bit more clearer. But definitely rewatch the webinar with Cyril because it blew my mind at the stuff that he knows.
Yeah, exactly. Cyril would be the one to go with all those questions. But yeah, any other question, guys? We're about to get out of time, but if anyone still has any questions that would like to share or ask why we approach it this way, why we ended up with WebSockets and not just Lambda string responses, any question, we can answer it now. If not, you can always leave a comment on the video itself or just add or join our Discord server. So if inside the Discord server, I'm pretty active in there. So any questions that might come my way, I'll try to ask as best as possible or get in touch with someone that can answer your question.
All right, I think we'll call time there. Bang on 1 hour, so that's good. I think we've run over the last couple, so there we go, right on time. Friday evening, we can all get to the pub. For those of you based in Europe, or based in England, there probably aren't many pubs in Barcelona, I assume, Lorenzo.
We have bars. It's
a tapas bar, yeah, exactly.
Yeah.
Perfect. Okay, so I guess sort of closing notes. Just remember, submit your all weekends to put the finishing touches on your submissions. Don't forget the video. Don't forget the article, and get both of them sort of published and public by that deadline. And sort of watch this space. Join the Discord server. Follow Serverless Guru, and Lorenzo and myself on socials. It won't be the last time we do something cool like this. And yeah, I think we'll call it there.
Perfect.
Thank you, everybody.
Thanks, everyone.